So how does a mineral form? The Earth's crust is rock, and rocks are made of minerals. And you'll find that there are 8 primary or 8 very abundant elements that make up the constituent or the majority of all of the rocks on Earth. So we'll explore further. So a mineral has characteristics. It must have these 5 characteristics. In order for it to be a mineral, it must be naturally occurring, inorganic, a solid, have an orderly crystalline structure, and have a well-defined chemical composition, and it can vary within some specific limits. But these are some minerals that we will get to know in our class. And we've got different colors, different characteristics, different ways, different compositions, different ways in which the atoms come together, that all of them lead to different properties. So we'll explore this a little bit further. So before we talk about the minerals, let's make sure we define what it is we're looking at. We're looking at the rocks of the Earth's crust. The Earth's crust has 2 primary types of rocks within its solid surface. When we talk about the crust itself, we'll talk about continental crust, which we'll call granite, and oceanic crust, what we'll call basalt. So the thinnest layer of the Earth is by far the crust. There are 2 types of crust. Continental crust, that this is what the continents are built upon, and it's called granite. And there's oceanic crust. The oceans are found above this rock, and this is called basalt. So the crust is simply the thinnest layer, and when we start talking about where we get our resources from, we're really talking about generally continental crust. Inside the Earth is hot, so hot that rock is a liquid, and this is called magma. So let's take a trip into the Earth, literally inside the Earth itself. Temperatures and pressures increase as one travels inward towards the center of the Earth, or the core. So heat is in motion via convection cells. Convection transfers hot material upward and cooler material downward. When hot material reaches new conditions and new temperatures that are below the melting point of the minerals, the liquid rock crystallizes or solidifies. This is one of the most common ways in which minerals form on Earth. So how minerals form? Well, the process by which atoms are arranged to form a mineral, or any material, with a repeated crystal structure. So minerals can form as hot magma cools deep inside the Earth's crust, or as lava hardens on the Earth's surface, right? Some, like say, from a volcano. When these liquids cool to a solid state, they form the mineral crystals. So minerals form under a variety of conditions, from deep inside the Earth to on the crust's surface. So 2 ways in which minerals form. The crystallization of a magma. Here you can see that rocks that form on the surface are going to be similar but yet slightly different than the rocks that form deep within the Earth itself. A second way in which minerals form is through the crystallization of materials that are dissolved in water. So let's think ocean water for a second. It's got a lot of salt in it. Salt is NaCl. So you get these ions that are kind of free floating in the water that are equally distributed within the water. So I don't know if you can see it or not, but those are H2O, so water. So once we remove the water, the NaCl then recombines and crystallizes into what we know as salt. So the size of a mineral crystal is determined by where and how long it took to solidify. So minerals that crystallize at or above the Earth's surface solidify relatively quickly. So they become fine or small crystals intergrown into one another. But minerals that form at depth or below the Earth's surface take longer. There's a greater time to solidify or crystallize. These crystals are considered coarse or large due to considerably longer crystallization time. So let's go back and look at the salt water here. Salt crystallizing out of salt water. So imagine a beaker of salt water that is left out for a period of time. The salt, NaCl, is dissolved in the water, creating a solution. As the water evaporates, only H2O escapes, right? It's only the water vapor that's evaporating, or the liquid water that's evaporating. The salt is left behind. As the precipitate forms, the Na and the Cl restructure themselves in a pattern called a cube, and we can see a picture here. The Na and Cl always combine to form this cubic pattern. So this is an identifiable characteristic, among others, as to identifying the mineral halite, or table salt. That salt minerals break into cubes, so they just simply reflect the atomic structure of how they formed and what they look like internally. So rocks, like granite and basalt, are made of minerals. So granite, we've identified continental crust, and basalt, we've identified as oceanic crust. Granite is a polymineralic rock. It's obvious by looking at granite, or continental crust, that it is polymineralic, or composed of many light minerals. But notice it does have dark minerals in it, but mostly, on average, it has lighter mineral composition. You can see them visually. You can just see them in here. However, basalt, or oceanic crust, appears to be one color. but it formed at the Earth's surface, so the minerals crystallized very quickly, and thus you cannot see them clearly with the naked eye. Basalt is a polymineralic rock that's comprised of several dark minerals, and those dark minerals include amphibole, pyroxene, olivine, and plagioclase feldspar. So here we can apply this granite formed at depth, it crystallized at depth, whereas basalt crystallized at or near the Earth's surface, so it crystallized relatively quickly. And we can see that when we look at this picture here. Minerals that crystallize above the surface have very, very small or fine crystals. And those that took to crystallize at depth just have so much more time to crystallize that they are coarse grained. So granite formed at depth and basalt formed at the Earth's surface. So let's tie this all together. The Earth houses all of the resources that we need to live our lives. And as we look at a picture of the Earth, we have to make sure that we realize we use the continental crust and we get all of our resources. We extract them from here. So we are fully dependent on the Earth and what it provides. We take what we need and mass produce it to make it readily available. Energy is a big one that gets most notoriety, but it is among many other of the resources that we get from. We can talk about hard rocks in mining. We can talk hydrocarbons or fossil fuels, aggregates that we kind of build our homes and our world from, salt, geothermal energy, water, recycling, timber, right, wood, we build structures, and energy, solar power. So we literally harvest the earth for resources that we use in our lives. So natural resources, what are they? Well, air, water, and soil. Biological resources involving plants and animals, right? We grow our food. That's a form of a biological resource. We've got raw materials like minerals and ores, the space and land, wind, geothermal, tidal, and solar energy. But what we're looking at here, we're comparing natural resources that we classify into either renewable, flow, or non-renewable resources. The picture here to the left, includes an open pit mine. An open pit mine is just where we directly go in and dig out and get what we need. We separate it. We'll talk about the separation process a little bit later. And geothermal, a renewable resource where we actually use the heat within the earth to essentially vaporize water and create pressure to turn a turbine. We can get electricity and thus heat from it. And this is all just heat that we take from the earth. So the earth provides the resources that we live our lives